one period. The letters for secant and cosecant work pretty much the same as sine and cosine. We have the A, we have B, C, and D. Was it D? Do you remember? D was vertical shift. C over B was phase shift. Right? 2 pi over B was what? Period. A is what is different. A is still there, but I'm going to show you what A is here in just a minute, okay? Now, so the period of this is cosecant. The period of cosecant is 2 pi. Because what's B in this problem?
2 pi.
1.
Oh, 1.
Not the period, what's B? B is what's in front of X. B is what's in front of X, right?
Yeah.
So we okay with that? All right, in order to graph this, I'm going to show you what the cosecant graph looks like. Okay? First thing I'm going to do is graph the sine of X. Can you all do that? No problem? And doesn't it do this? Since you all just did this, this should be easy, right? What's wrong?
I just graphed the cosecant. It is very weird.
But I'm going to show you why it's weird. Isn't cosecant 1 over sine? Isn't it? Okay. So, right here, what is the value of sine?
0.
0. Cosecant is 1 over 0 then. 1 over sine. What is 1 over 0? Undefined. So there's an asymptote here. Do you all know what asymptotes are?
No.
They are dotted. What'd you say?
I remember the word, but not what it is.
An asymptote is a dotted line on the graph where it's undefined. That's all it is. Was it undefined at 0?
Yeah.
So that's why I drew an asymptote. All right? Guess what's going to happen at pi? What is sine value at pi? 0?
Oh, pi.
0? So guess what's going to be at 0? Another asymptote. Do you see where a third asymptote will be? 2 pi. Right? What value is the sine graph right here? 1. What's the reciprocal of 1? 1. So the cosecant graph has a dot right here. Now I'm going to ask you a question. Right about here, is my y value 1/2?
Yeah.
What's the reciprocal of 1/2? So up here is going to be a dot?
Oh my god.
Whoa.
And that can go on forever though, right?
Well, yes, just like the sine graph goes forever. So, would you agree here is 1/2?
Wouldn't that go up forever though?
Would you agree here's 1/2?
Yeah.
So it's going to be a 2. So the cosecant graph, that's half of it. Well, sort of, not exactly. The cosecant graph gets closer and closer to my asymptotes, but doesn't ever cross them.
So it's like a new graph every single time.
Is it that other
Right.
thing that curves south, but like it never actually crosses the x-axis?
Yes, we're going to do lots with asymptotes. Look, what do you think this one's going to do?
Same thing
Oh,
with
same
flips,
thing, but
negative.
upside down.
The same thing, but upside down. Like that? So, the cosecant graph is the purple. And you don't have to graph the sine graph. I graphed it so I could show you what the cosecant does with the sine graph. That's what reciprocal does. All right? Now, would it keep going?
Yeah.
Sure it would. What A is on the graph is how far we are from the x-axis. Isn't this one? That's what the A is. There's no amplitude on cosecant because it kind of goes forever.
So A is just X. Or, yeah.
No, well, no.
Would it be?
It's how far it is from the x-axis, how far away it is,
So
up
it's
and down.
Oh, up and down.
I was thinking maybe for a second would A possibly be like the inequality concept where it's like when
So is it
y
Y then?
is greater than A, and A is
No, no, no. All right, that's what a cosecant graph looks like. Secant does the same thing with the sine graph. All right? Or with the cosine graph.
Okay.
Sorry. So, doesn't cosine look like this? So what do you think secant would do? Where do you think an asymptote would be?
Pi over 2.
Pi over 2? You agree? Where else? 3 pi over 2? All it does is turn it upside down. So the secant graph, and by the way, there would be another one over here, wouldn't there? Like this. And then like this. Whoops. It should go to my asymptote. And it would go to an asymptote. Because it keeps repeating. Now that we have a clue, they're going to have asymptotes, and they're going to have parabola-like looking things. They're not, parabolas don't stick straight up. They keep going out. But they're sort of looking like that. So knowing that, can we graph one on the calculator? All right? Now you're all going to have to think how to put this one in your calculator. Because can I give you a hard one?
Yes.
Yeah, okay. Y equals 2 cosecant 2x plus pi over 4 plus 1. Now, this is not going to be extremely hard to graph. One of the hardest things is going to be putting it in your calculator correctly. Okay? Go to your window. We're graphing one period. 1 period. So on your window, what is x minimum? 0. I fooled you, didn't I? We always start at 0. What is x maximum?
X maximum is 2 pi.
I want 1 period. What is x maximum? What's the period of this?
It's 1 pi.
It's 1 pi, isn't it? Isn't this b right here? Just like sine and cosine, the letters are all there. Isn't that b? So is my period pi? Okay, so x maximum is pi, right? What is my phase shift?
Pi over 8.
Pi over 8. Do we agree? Everybody okay with that? And what's the vertical shift? Up, right? Okay, so you've got x minimum, x maximum, x scale is normally what?
Period divided by 4.
The period divided by 4. But look what the phase shift is. So I would say your scale is probably pi over 8. Right. Since 8's the common denominator between the two. We okay with that? All right. What about y? It's up 1, isn't it? Now remember, these graphs are going to go up and down as far as they can go. So there's not going to be, you're not going to be able to see the top or the bottom of the graph, are you? Does that make sense? So -5 to 5 maybe? How does that sound? Sound okay? You can adjust it if you need to, can't you? All right. Now, what? -5 to 5. When you put this in your calculator, isn't cosecant 1 over sine? So this is going to be equal to y equals 2 times 1 over sine. What is my angle? All that goes with the word sine is what is in parentheses, which is 2x plus pi over 4. And then your plus 1 goes off to the side.
Oh, it goes up to the side.
Yes. Do you have it? Does yours look like somebody else's? What? Go through this one. Why does it not like sign down there?
What did mine was getting 6 or 2 over?
I wonder if you need a times.
Oh, the 2. Is that where they're not at times by the 2?
No.
Yeah, that's where mine messed up at. You added 2 times.
Where's your graph? He has his in just like you.
What's the window?
His window is 0 to pi, -5 to 5,
Maybe it's not in radians.
That's what it is.
Boom.
Good job, Sammy.
Should I get bonus points for that? No. That would be nice, though.
Just looking at your pictures. All right. Is it there now?
Yes.
Much better. I'm like, everything looks perfect. So, we have to draw our graph. Didn't we do the scale to be pi over 8? Remember, you want your graph, same as your calculator, right? This is pi over 8. Right? The first thing we graph for the asymptotes. Can somebody tell me where an asymptote is? When you trace and you pick in put in, you think what?
3 pi over 8.
Okay, trace 3 pi over 8. And sometimes it kind of is. What'd you get for 3 pi over 8?
I'll take that.
Negative 2 e to the 13th, which is like negative 2 trillion, which means we're way down. So that means you are out of asymptote. So your calculator will not give you the asymptotes. You have to find them. Or use your, it's like you said, I think this is where it must be.
So does it technically cross then?
No,
No, it never crosses.
no. It's just so close it rounds it to that. So you're telling me that I should have an asymptote here,
Yes.
right? Do we agree? Now, there is an asymptote every half a period. Do you agree? Every half a period, isn't there an asymptote? So on this one,
Negative pi over 8. And also 5 pi over 8.
I don't think 5 pi is it? 7 pi over 8.
Oh, yeah. Yeah, that's 5. That's my bad.
Do you all agree? Your graph is going to kind of follow your asymptotes. So that's why we have to find those first. Now, somewhere in here is the lowest point or highest point of my graph. Highest. Somewhere in this area.
Oh, our sine graph?
3. Oh, wait.
3?
What's going on?
I need a point for my graph.
It's at 3.
It's at 3 what?
Pi 8 over 3.
That's what I needed. Pi over 8 and 3?
Is it 3 because of the 2 and then the 1?
Yes. Yes. We moved it up 1, and then we went up 2. Right? You okay with that?
Why is that so high?
Because our vertical shift is 1. And then the amplitude for sine would have been 2, which means I would have gone up 2 more. Or down 2 more. Can anybody tell me where I am at 0?
You're at 3.8. 3.828.
Can you graph that good?
You can graph
I bet.
3.8.
You can get pretty close to 3.8. Right? So maybe about right here is where it starts, and then it does this, Would you agree? Everybody okay with that? Now, somewhere in here, I need a value. Well, okay, this is 3 pi over 8. This is 7 pi over 8. So my point's going to be in the middle. What's between those two? 5 pi over 8. And when you trace that, what did you get? Negative 1. And that makes sense, doesn't it? Because I had a shift of up 1, and from there I went up 2 and down 2. The graph kind of should make sense to you. Does it?
Yeah. So you just need to put those two graphs and call it a day.
Well, don't call it a day. Finish it. Finish doing, because I have one more piece. Hang on.
Oh, yeah.
Hang on. You okay with that? Now, it is a sketch graph. I wanted the points, so I knew where it started. But other than that, it's following the asymptotes, right? Now, we graphed a full period. Aren't I missing a piece of this one? Aren't I? And where would it be? It would be over here, wouldn't it?
Oh, that one. Oh, yeah, sure.
Wouldn't it?
Oh, yeah.
Like that? Didn't I take a piece off of this one right here? And it would, so it would be back over here, wouldn't it?
Technically, that's a different thing, but it's like the start and
But I'm doing a whole period, so I have to go. Wherever I start here is where I have to end here. Left and right have to match the same. Does that make sense to you?
Yeah.
We okay? You think you can do it?
Yep.
You're kind of getting a little more used to the calculators, aren't you? Where you can.
it's really similar to the sine and cosine.
It is very similar. We just are going to flip them up. The hardest thing on this is getting it in your calculator correctly. And remember, the only thing that goes with the word sine and cosine is what's in parentheses. And finding your asymptotes. Once you found your asymptotes, it's kind of easy to draw the graph, isn't it? Okay, can we do this?